So hello, this is Group 20 and I'm Long Locking, and this project aims to benchmark Docker application to be more precise in different EC2 instances so that we can know uh, which type of instances is best for different scale of Docker application with Docker container. So to do this, to we first to create three instances, which is T2 medium, T2 large, and T2 small. And we run first run basic branch marking script, which is basically the same as what we did in assignment 1, and also we'll try to run two Docker samples project. The first one is this tweet app. Is a website that allows users to send a tweet by referring them to Twitter or X. So this is try to check how it handles simple network requests as it refer the user to another website. And as for the other project, it is a voting application. So it is a distributed application that runs across different Docker container. So as you can see from this diagram, the voting app is running on Python, and for the result, it will run on Node.js. The vote are managed by Redis, and as for the vote result, it is saved in a Progress database backed by a Docker folder. So this voting app can simulate how a rather complex application will work with Docker on the EC2 instances. So to do this, as we mentioned, we'll use different script to like install the Docker basic branch marking to deploy the project, which has been done already. So we'll first try to do some branch marking, basic branch marking on the instance, as you can see here. So we'll install sysbranch and then start to run the CPU utilization branch marking first. As you can see here from the CPU how long it takes to run the test. And as a small summary for the result, T2 medium and T2 large has a better file I/O read and write rate, but all three instances share similar CPU utilization, transfer speed, and time to process the request sent by branch. Okay, either way. Either way, so we'll run on the branch marking script first. So deploy the tweet app. So to run the script, we'll copy and paste the IP address with the port number. As you can see, like I'm trying to send a tweet. Try do it a few times over a minute. So we'll try to run the tweet app branchmark script. We'll copy copy and paste this URL monitoring the tweet app. So like when I press the button, it will lead me to Twitter. As you can see, it will have different transfer and receive value from the network request leading to another website. And you can see the disk is writing because it's writing some log, but this is really minimal. So after a minute, then a summary report will appear. Yeah, as you can see here. So moving on to the voting app. Similarly, copy and paste the URL with the correct port number. So like this, I try to vote, and I can change the vote. And on the other website, you can see it refers back almost instantly once the results are loaded in. And for the EC2 terminal, you can see the CPU is using, and it has a lot of write and commits with a little bit of rollback. And the performance is rather nice. So either way, as you can see, it shows the CPU utilization, and the registry has the vote because it does not have to wait for the request, and the average write and commit is like this, and the vote latency is rather small, as you can see. So yeah, that's basically all about it. And the result that we found is for smaller application with not that many file I/O operation, actually it works better. For the smaller instances work better. So T2 small actually works better in these cases. But for application that needs to work across multiple instances, like multiple container, like the voting app, T2, at least T2 minimum will work significantly better than T2 small, and for larger instances, it can have a better performance by having a smaller latency and a more rapid read and write rate to the database. That's all for the demo video.